Good morning, all of you. Now I'm going to discuss about harmonic distortion analysis. So, harmonic distortion analyzers are an example of wave analyzers. So, in the last class, we have discussed what is a wave analyzer. So, a wave analyzer uh, is used to measure or analyze a particular wave, or you need to measure a particular frequency. Then these wave analyzers can be used, and these wave analyzers are classified as two types. Those are frequency selective wave analyzer and heterodyne wave analyzers. So in the frequency selective wave analyzer, we are measuring the frequencies of audio signals, and the frequencies of radio signals can be measured by using the heterodyne wave analyzers. And the applications of these wave analyzers we have mentioned as the first one as it is used to measure harmonic distortion of a signal. So that we are going to discuss now. So harmonic distortion analyzers are the analyzers which are measuring the total harmonic distortion of a wave. And what is the meaning of distortion? So distortion can be caused by many devices. Like means if you are using a FET or JFET electronic devices or some other purposes also, the wave, instead of getting the input whatever the signal you are giving, instead of replicating the same wave, it is distorted. The output is different from the input wave. That means there is some amount of distortion happening. So, what are the different types of distortions that are occurring in a circuit are frequency distortion, phase distortion, amplitude distortion, intermodulation distortion, and crossover distortion. So, frequency distortion means in the frequency you are getting something distant. Instead of getting the frequency which we have given input, the frequency has changed to some other frequency, so that the frequency has been distorted. Likewise, the in phase also, instead of having the phase which we are giving as input, the phase has been changed, or the amplitude has been changed, or modulation has been changed, or during the crossovers. Crossover means if you are having a sine wave will be crossing at the during the interval pi, it is going to cross. So during the from positive wave to negative wave, it is going to cross at pi. So at that crossing time, you are getting the distortion. That is called crossover distortion. Likewise, here in any of these distortion is happening. These are the different types of distortions. So in this harmonic distortion analyzers are used to measure this amount of distortion which is happening in the signal. Okay. Now we shall discuss about the total harmonic distortion analyzer. So it consists of several methods. Now we are going to discuss about the bridge T network method, by which you can measure the total harmonic distortion. So in this bridge T network method, you are having a T network. So this is the T network which we are considering. Here you are using a LC filter. So this LC is nothing but the tank circuit which you are framing here. This is the tank circuit, and in between here a variable resistance is used. So here you are mentioning that this is a variable resistance. That means by varying this resistance, you can tune the circuit to a particular frequency. Okay, so that means if you give a test wave here for which you need to measure the harmonic distortion, so that test wave is passed through the LC filter, and this LC filter will allow only the frequencies which are greater than the fundamental harmonics, which are having more than the except the first harmonic. The first this R is adjusted such that the first harmonics can be bypassed here. That means the first harmonics will be coming here and going to R, and it is going to the text wave. That means the first harmonics gets circulated here, and the remaining harmonics will be getting as the output. This harmonic distorted output consists of only the harmonics other than the fundamental harmonics. So, so that means you cannot measure the first harmonic here. Only the other harmonics, for other harmonics you can measure the harmonic distortion. So that for that total harmonic distortion, how much it is, you can measure here. So for that, this is the bridge T network. So this bridge T network is used in this block diagram. This is the bridge T network. Now this is the total harmonic distortion amplifier block diagram. So in this, the test wave which is going to be, for which you need to measure the THD, that is total harmonic distortion, is given to the amplifier. So what does this amplifier does? This amplifier will amplify the weak signals into the, will strengthen the weak signals into the required signal. That signal is connected to the adjustable attenuator. So adjustable attenuator means you can stop the required whatever frequencies you want to stop, that can be stopped, and if you want to allow certain type of frequencies, that can be allowed. So this can be done by the adjustable attenuator. And here this is the bridge T network, and this bridge T network we have already discussed here, and this is the output meter in which you can observe the output. Here you are using a switch here. This is the switch. This switch can be moved to position A or position B. Now consider the switch is in position A. That means the input wave comes here, and it will be going through the amplifier and adjustable attenuator and through the switch and going to A. So that and amplifier, and this is coming here and is going through the BGT network and going to the output. So the test input wave is entered in the amplifier and going to the A and the switch and BGT network and output meter. That means this adjustable attenuator is bypassed here. Is bypassed. Only the bridge T network is going here, so that the output meter will show the total harmonic distortion of the remaining harmonics except the fundamental harmonic. And if you want to allow the other frequencies, then you can move to the switch is moved to position B, so that the waveform input is given to the amplifier, next adjustable attenuator, next is going to B, and it is going to output. Here bridge T network is bypassed here, so that only the attenuation components can be displayed here, so that this output meter will always show the will calculate the total harmonic distortion except the fundamental harmonic. Okay? And the advantages of this total harmonic distortion amplifier is this circuit is very simple and the cost is less. Only here you are using a T network, the circuit is very much simple and it is easy to design, so that the cost is also very much less. And the disadvantage is the amplitude of the individual harmonics cannot be calculated. So if you are calculating only the total harmonic distortion. If you want to measure the amplitude of a particular harmonic, then this cannot be done by using the THD. So that is one of the disadvantages of this total harmonic distortion analyzer.